Gem mining and mining in general are fascinating fields that involve extracting valuable resources from the earth. Here's a breakdown of both. Gem mining. Gem mining focuses on extracting precious and semi-precious gemstones, such as diamonds, emeralds, sapphires, rubies, and opals. There are several methods used. Alluvial mining. Gems are collected from riverbeds and sediments. Open pit mining. Large surface areas are excavated to access gems. Underground mining. Used when gem deposits are deep within the earth. Sluicing and panning. Common for finding gems like sapphires and garnets in rivers. Artisanal mining. Small scale, often manual mining done by individuals or small groups. Major gem mining locations include Myanmar rubies, Sri Lanka sapphires, Colombia emeralds, and South Africa diamonds. Mining general. Mining refers to extracting minerals, metals, and fossil fuels from the earth. Key types include surface mining, for example, open pit, strip mining, used for coal, copper, and bauxite. Underground mining used for deeper deposits like gold and zinc. Placer mining, similar to alluvial gem mining, but for metals like gold. In situ mining, a chemical process for extracting minerals without traditional digging. Mining has shaped civilizations, fueling industries from construction to technology, but also has environmental and ethical concerns, leading to regulations and sustainable mining initiatives. Gem mining and mining, a deeper look. Mining is one of humanity's oldest industries, dating back thousands of years. When early civilizations extracted minerals, gemstones, and metals for tools, jewelry, and trade. Today, it has evolved into a highly technical and large-scale industry, supplying materials for everything from electronics to construction. Gem mining. Gem mining is a specialized branch of mining that focuses on extracting precious and semi-precious gemstones from the earth. These gems are later cut, polished, and used in jewelry, industrial applications, and even scientific research. Types of gem mining. Alluvial placer mining. Gems are found in riverbeds, floodplains, or beaches where erosion has washed them down from their original deposits. Common for diamonds, sapphires, garnets, and gold. Methods include panning, sluicing, and dredging. Open pit mining, a large-scale method used for gems located near the surface, involves removing overburdened surface material to expose the deposit. Common for opals, Australia, and some diamond mines. Underground mining, used when gem-bearing deposits are deep underground. Miners tunnel into the earth, following gem veins. Common for emeralds, Colombia, rubies, Myanmar, and sapphires. Hard rock mining, extracts gems embedded within rock formations. Requires blasting, crushing, and sorting to recover gemstones. Often used for diamonds and beryl. Emerald, aquamarine. Marine mining, used primarily for diamonds. Involves dredging the ocean floor to extract gem-rich gravels. Common in Namibia and South Africa. Artisanal and small-scale mining, ASM. Hand-dug mines operated by small groups or individuals. Labor-intensive but a major source of gems in developing countries. Often leads to ethical concerns regarding fair wages and environmental damage. Famous gemstone mines. Colombian emerald mines, Musochivar and Cosquez, produce some of the world's finest emeralds. Mogok, Myanmar, known for the best rubies in the world, often called pigeon's blood rubies. Ratnapura, Sri Lanka, famous for sapphires of all colors. Argyle, diamond mine, Australia, produced rare pink diamonds before closing in 2020. Tanzanite mines, Tanzania, the only known source of tanzanite, a rare blue-violet gem. Challenges in gem mining. Environmental impact, land degradation, water pollution, and habitat destruction. Ethical concerns, blood diamonds, and unethical labor practices. Market fluctuations, gem values can be volatile, affecting local economies. Mining general. Mining provides raw materials for industries such as construction, electronics, and energy. The mining sector includes a variety of methods depending on the resource being extracted. Types of mining. Surface mining includes open pit, strip, and mountaintop removal, used for coal, copper, iron, and bauxite. Underground mining, used when deposits are deep below the surface. Examples: gold mines in South Africa, silver mines in Mexico. Placer mining, uses water to separate heavy metals from sediments. Historically famous in the California gold rush. In situ mining, uses chemicals to dissolve minerals underground. Common for uranium and lithium extraction. Deep-sea mining targets minerals on the ocean floor. Highly controversial due to potential ecosystem damage. Notable mining locations. Carlin Trend, Nevada, USA, one of the richest gold mining areas in the world. South Africa's Witwatersrand Basin produces a significant portion of the world's gold. Chilean Copper Belt, home to the world's largest copper mines. Siberian diamond mines, major source of Russian diamonds. Challenges in mining. Environmental impact. Deforestation, pollution, and habitat destruction. Resource depletion. Some deposits are being mined faster than they can be replenished. Safety risks, cave-ins, gas leaks, and explosions pose dangers to miners. Ethical issues, human rights violations in some mining regions. Future of mining. Sustainable mining. Eco-friendly techniques like reforestation and water recycling. Artificial gem production. Lab-grown diamonds and synthetic sapphires reducing the need for mining. Automation and AI. Robots and AI improving efficiency and worker safety. Space mining. Plans to extract minerals from asteroids and the moon in the future. The world of gem mining and mining. A deep dive. Mining, including gem mining, has played a crucial role in human history, fueling economies, technological advancements, and artistic expression. While mining provides the raw materials for industries worldwide, it also raises concerns about environmental sustainability and ethical labor practices. Let's explore mining in greater detail. Gem mining. Unearthing nature's treasures. Gem mining involves the extraction of naturally occurring precious and semi-precious stones from the earth. These gems undergo cutting and polishing before being used in jewelry, electronics, and even industrial tools. Major gemstone categories. Precious gems, diamonds, rubies, sapphires, emeralds. Semi-precious gems, amethyst, topaz, aquamarine, garnet, peridot, tourmaline. Rare gems, tanzanite, alexandrite, paraba, tourmaline, grandidiorite, black opal. Famous gem mines and locations. Burma, Myanmar, rubies and jade. The Mogok Valley has produced some of the most valuable rubies in history, characterized by their deep red color. Colombia. Emeralds. Muso Shiver and Cosquas are legendary emerald mines, known for producing vibrant green, high-clarity stones. Sri Lanka sapphires. The gem island is famous for high-quality blue sapphires, pink sapphires, and rare Padparacha sapphires. Brazil tourmaline and topaz. Brazil is a major producer of colorful gemstones like Paraiba tourmaline, which is one of the most valuable gems in the world. Australia opals and diamonds. Lightning Ridge produces the rare black opal, while the Argyle mine was the world's top supplier of pink diamonds. Mining techniques for gems. Traditional methods. Panning and sluicing, used in rivers and streams to collect loose gemstones. Hand digging and artisanal mining, often used by small-scale miners in developing countries. Industrial methods. Open pit mining, large-scale excavation used for diamonds, emeralds, and opals. Underground mining, used for deep gemstone deposits like emeralds and rubies. Modern and sustainable techniques. Laser drilling and controlled blasting. Minimizes damage to gems. Eco-friendly extraction. Uses biodegradable chemicals and water recycling to reduce environmental impact. Challenges in gem mining. Illegal mining and smuggling. Many gem-rich countries struggle with illicit mining operations. Ethical concerns, blood gems, unethical labor practices, and conflicts over gem resources. Market instability. The value of gems fluctuates based on demand, rarity, and new discoveries. General mining. Extracting Earth's resources. Mining is the process of extracting minerals, metals, and fuels from the earth. These resources are essential for industries like construction, manufacturing, and technology. Major mining sectors. Metal mining, gold, silver, copper, iron, aluminum, lithium. Coal and fossil fuel mining, coal, oil sands, natural gas, uranium. Industrial mineral mining, limestone, salt, gypsum, quartz, rare earth elements, neodymium, yttrium, lanthanum, used in electronics and green energy. Major mining countries. China, leading producer of rare earth elements, coal, and gold. Australia, major source of iron ore, bauxite and gold. Russia, rich in diamonds, platinum, and nickel. United States produces coal, copper, and gold. Nevada and Alaska are key mining states. South Africa, historically dominant in gold and diamond mining. Types of mining methods. Surface mining, open pit mining, used for minerals like copper, diamonds, and iron ore. Strip mining, common for coal and bauxite. Mountaintop removal, used for coal but highly controversial due to environmental damage. Underground mining, drift mining, horizontal tunnels into mountains. Shaft mining, deep vertical tunnels, used for gold and diamonds. Room and pillar mining, used in salt and coal mines. Placer mining, extracts minerals from riverbeds using gravity separation. Historically important in gold rushes. In situ mining, uses chemicals to dissolve minerals in place. Common for uranium and lithium extraction. Deep sea mining, extracts minerals from hydrothermal vents and sea. Potential for nickel, cobalt, and rare earth metals. Technological advancements in mining. Automation and AI in mining. Autonomous trucks and drills increase efficiency and safety in mining operations. AI and machine learning helps predict mineral deposits and optimize mining processes. Remote sensing and drones, used for surveying and monitoring mines. Sustainable mining initiatives. Green mining focuses on reducing environmental impact by using eco-friendly extraction methods. Recycling and circular economy, extracting metals from e-waste instead of traditional mining. Carbon capture and restoration. Mining companies are investing in carbon capture technology to offset emissions. Space mining, the future of resource extraction. Asteroid mining. Companies like NASA and SpaceX are exploring mining asteroids for rare metals. Lunar mining, the moon has potential resources like helium-3 and rare minerals for space travel. Challenges, cost, technology, and legal issues surrounding extraterrestrial resource ownership. The impact of mining on society and the environment. Positive impacts. Economic growth. Mining industries contribute to national economies and create jobs. Technological development. Advances in extraction, processing, and sustainable mining. Infrastructure development. Mining leads to the construction of roads, railways, and cities. Negative impacts. Environmental damage. Deforestation, soil erosion, and water pollution. Health risks. Exposure to harmful chemicals and dust. Conflict mining. Some mines fund warlords or exploit workers, for example, blood diamonds. Final thoughts. Mining is a double-edged sword. It provides the raw materials that fueled civilization but comes with ethical and environmental concerns. The future of mining will likely be shaped by green technology, automation, and possibly even space exploration. Mining and gem mining are vast and intricate industries that have shaped human civilization for thousands of years. Let's take a deep dive into every aspect of these fields, covering history, types, famous mining locations, techniques, environmental impact, technological advancements, and future trends. Gem mining. Extracting nature's jewels. Gem mining focuses on extracting naturally occurring precious and semi-precious stones from the earth. These stones are then cut, polished, and used in jewelry, art, and industry. A history of gem mining. Ancient Egypt 3000 BCE. Egyptians mined turquoise in the Sinai Peninsula and used lapis lazuli for jewelry and burial masks. Ancient Rome and Greece. Ruby, sapphire, and emerald were highly valued and traded across the Silk Road. Mesoamerica Aztecs, imagens. Jade was considered sacred and used for ceremonial masks and tools. Medieval Europe. Diamonds from India's Golconda region adorned the crowns of European monarchs. 19th and 20th century. Industrial-scale mining emerged, particularly in Africa for diamonds and South America for emeralds. Major gemstone categories and their sources. 1. Precious gems, rarest and most valuable. Diamonds, Russia, Botswana, Canada, South Africa. Rubies, Myanmar, Burma, Thailand, Mozambique. Sapphires, Sri Lanka, Kashmir, Madagascar, Australia. Emeralds, Colombia, Zambia, Brazil. 2. Semi-precious gems, common but valuable. Amethyst, Brazil, Uruguay, Russia. Topaz, Brazil, Mexico, Sri Lanka. Aquamarine, Pakistan, Madagascar, Nigeria. Garnet, India, Sri Lanka, Russia. 3. Rare and exotic gems, tanzanite. Tanzania, the only known source. Alexandrite, Russia, Brazil, Sri Lanka. Paraíba, tourmaline, Brazil, Mozambique, Nigeria. Opal, black opal, Australia. Lightning Ridge, Ethiopia. C. Gem mining techniques. Alluvial placer mining, Gems are washed from riverbeds or floodplains, using panning, sluicing, and dredging. Open pit mining used when gem deposits are near the surface, common for diamonds and opals. Underground shaft mining. Tunnels are dug to extract gems embedded in rock formations. Hard rock mining uses explosives and drills to break apart mineral-rich rock to access gems. Marine mining. Dredging the ocean floor for diamonds, primarily in Namibia and South Africa. Artisanal and small-scale mining. Manual digging, often in developing countries, making up a significant portion of the global gemstone trade. Famous gem mines around the world. Muso Chiver and Cosquest Mines, Colombia, source of the world's highest quality emeralds. Mogok Valley, Myanmar, the Valley of Rubies, home to legendary pigeons, blood rubies. Ratnapura, Sri Lanka produces a wide variety of sapphires, including rare ped. Argyle Mine, Australia, once the largest producer of pink diamonds. Mining.Environmental, Russia, massive diamond mines in Siberia. Challenges and ethical concerns in gem mining. Illegal mining and smuggling. Many gems are sourced from unregulated operations, fueling crime. Blood gems and conflict minerals. Some gems fund wars and human rights abuses. Environmental damage, deforestation, water pollution, and soil erosion. Worker exploitation, child labor and unfair wages in some regions. 2. General mining, extracting Earth's resources. Mining is essential for extracting minerals, metals, and fuels that power modern civilization. Types of mining. Surface mining, open pit mining, used for copper, gold, and diamonds. Strip mining, common for coal and bauxite. Mountaintop removal, extracts coal, but devastates ecosystems. Underground mining, drift mining, horizontal tunnels into hillsides. Shaft mining, deep vertical tunnels, used for gold and diamonds. Room and pillar mining, used for salt and coal. Placer mining uses water-based separation techniques to extract gold and gemstones from river sediments. In situ mining uses chemicals to dissolve minerals in place, common for uranium and lithium. Deep sea mining targets minerals in hydrothermal vents and seabed. Major mining regions and resources. China, largest producer of rare earth elements, coal, and gold. Australia, major exporter of iron ore, bauxite and gold. Russia dominates platinum, diamonds, and nickel. United States produces coal, copper, and gold, with major operations in Nevada and Alaska. South Africa, historically rich in gold and diamonds. Technological advancements in mining. Automation and AI. Autonomous mining trucks and drills improve efficiency and safety. AI-driven mineral exploration increases discovery success rates. Green mining initiatives. Renewable energy use in mines, solar, wind, water recycling systems to reduce pollution. Urban mining and e-waste recycling. Extracting rare metals from electronic waste, phones, laptops. Space mining. Future missions may extract metals from asteroids and the moon. Environmental and social challenges in mining. Deforestation and land degradation. Mining disrupts ecosystems and landscapes. Water pollution. Toxic chemicals like mercury and cyanide contaminate rivers. Resource depletion. Some minerals, like high-grade iron ore, are becoming scarce. Human rights violations. Forced labor and unsafe working conditions in some mines. 3. Future of mining and gem mining. Sustainable mining and ethical sourcing. Companies are investing in eco-friendly mining to minimize damage. Blockchain technology is being used to track ethically sourced gems. Rise of lab-grown gems. Synthetic diamonds and sapphires offer ethical alternatives. Asteroid and lunar mining. The next frontier in mineral extraction. AI and robotics. Smarter mining operations with minimal human risk. Conclusion. Mining, both for gems and general minerals, has been the backbone of human progress. While it fuels economies and industries, it also poses significant ethical and environmental challenges. The future of mining will depend on sustainable practices, ethical sourcing, and technological innovations to ensure a balance between resource extraction and environmental preservation. The ultimate deep dive into gem mining and general mining. Mining has shaped civilizations, driven economies, and provided essential materials for technology, infrastructure, and culture. Gem mining and general mining are two interrelated yet distinct fields, each with its own history, techniques, and challenges. This comprehensive guide will cover every aspect of these industries, from ancient mining practices to futuristic space mining. Gem mining, the world of precious stones. Gemstones are among the most sought-after natural treasures. The mining process varies depending on the type of gemstone and its geological formation. A history of gem mining. Prehistoric times. Early humans collected colorful stones, like amber, obsidian, and quartz. Ancient civilizations. Egyptians 3000 BCE, mined turquoise, lapis lazuli and emeralds. Romans and Greeks valued diamonds, rubies, and sapphires. Chinese dynasties. Jade was revered as the stone of heaven. Middle Ages. Trade routes. Expanded gemstone availability across continents. 19th and 20th century. Industrialization led to large-scale mining operations. 21st century. Advances in synthetic gems and ethical sourcing shaped the market. B. Types of gemstones and their sources. 1. Precious gems, rare and highly valuable. Diamond, Russia, Botswana, Canada, South Africa. Ruby, Myanmar, Burma, Thailand, Mozambique. Sapphire, Sri Lanka, Kashmir, Madagascar, Australia. Emerald, Colombia, Zambia, Brazil. 2. Semi-precious gems, more abundant but still valuable. Amethyst, Brazil, Uruguay, Russia. Topaz, Brazil, Mexico, Sri Lanka. Garnet, India, Sri Lanka, Russia. Citrine, Madagascar, Spain, Brazil. 3. Rare and exotic gems, limited geographic sources. Tanzanite, Tanzania, the only known source. Alexandrite, Russia, Brazil, Sri Lanka. Paraiba tourmaline, Brazil, Mozambique, Nigeria. Black opal, Australia. Lightning Ridge, Ethiopia. C. Major gemstone mining locations. Mogok Valley, Myanmar. Valley of Rubies, Muso and Chiver Mines, Colombia. World's top emeralds, Ratnapura, Sri Lanka. Ancient sapphire mines. Argyle Mine, Australia. Famous for pink diamonds. Maranja, Zimbabwe. Rich in diamonds, but controversial. D. Mining techniques for gems. Alluvial mining, placer mining, collecting gemstones from riverbeds. Open pit mining, large excavations for gems near the surface. Underground shaft mining, deep tunnels to access gem deposits. Hard rock mining, extracting gems embedded in rock formations. Marine mining, sifting ocean sediments for diamonds. Artisanal mining, small scale, manual digging, common in Africa and South America. E. Challenges and ethical issues in gem mining. Blood diamonds and conflict gems, funding wars and unethical labor practices. Environmental damage, deforestation, soil erosion, water pollution, exploitation of workers, child labor, low wages, and unsafe conditions. Synthetic versus natural gemstones. Lab-grown gems are disrupting the industry. 2. General mining. Powering the world. Mining is essential for extracting raw materials used in construction, technology, and energy production. Types of mining and resources extracted. 1. Metal mining. Gold, South Africa, Australia, China. Silver, Mexico, Peru, Chile. Copper, Chile, a Democratic Republic of the Congo. Iron ore, Brazil, Australia, India. 2. Fossil fuel mining. Coal, China, India, USA. Oil sands, Canada, Venezuela. Uranium, Kazakhstan, Canada, Australia. 3. Industrial minerals. Limestone used in cement and construction. Salt extracted from underground deposits or seawater. Quartz, used in electronics and glass making. 4. Rare earth elements, essential for modern technology, including batteries, electronics, and green energy. Top producers: China, USA, Myanmar, Australia. B. Mining methods and technologies. 1. Surface mining. Open pit mining, extracts metals and minerals near the surface. Strip mining, used for coal and mountaintop removal, controversial method for coal extraction. 2. Underground mining. Drift mining, horizontal tunnels into hillsides. Shaft mining, deep vertical shafts for gold and diamonds. Room and pillar mining, used for coal and salt. 3. Advanced mining techniques. Heap leaching, extracts gold and copper using chemical solutions. In situ mining uses chemicals to dissolve minerals in place. Deep sea mining, extracts minerals from ocean beds. C. Major mining regions. China, #1 in rare earth metals, coal, and gold. Australia, rich in iron ore, bauxite and gold. Russia produces diamonds, platinum, and nickel. South Africa historically a top gold and diamond producer. USA leading in copper, coal, and rare earths. DI environmental and social impacts of mining. Deforestation and habitat destruction, especially from open-pit mining. Water pollution. Cyanide and mercury contamination from gold mining. Mine waste and tailings. Toxic byproducts from metal extraction. Worker safety issues, high risks of collapses, explosions, and lung disease. 3. The future of mining, a sustainable and green mining practices. Eco-friendly extraction, using renewable energy in mining. Water recycling, reducing freshwater usage in mining. Carbon capture technology, offsetting mining emissions. B. Technology in mining, AI and automation, self-driving trucks and AI-driven exploration, drones and remote sensing. Mapping and monitoring mines, 3D printing with mined materials, transforming raw materials into components. C. The rise of urban mining, e-waste recycling, extracting rare metals from old electronics, reprocessing mine tailings, recovering leftover minerals from old mining sites. DI space mining, the next frontier, asteroid mining. Companies like NASA, SpaceX and private firms are exploring asteroid mining. Lunar mining, the moon has helium-3, a potential future energy source. Challenges, high costs, legal ownership issues, and technological barriers. Conclusion. Mining, whether for gemstones or industrial minerals, has defined human progress but comes with major challenges. The future of mining will focus on sustainability, ethical sourcing, and technological innovation.